Hello, Miss Taylor here. I'm going to walk through all of the processes that we have so far of cellular respiration. So the first step is glycolysis. And it starts with glucose here. Glucose is a 1, 2, 3, 4, 5, 6 carbon molecule. The first step of glycolysis is investment. So what happens is 2 ATP are invested, meaning they are required, they are used, they are put into the system to add on phosphates to glucose. So glucose gets phosphorylated. The P's that are taken off of ATP are added to glucose. This is a very unstable intermediate, so it gets cleaved automatically. This is the cleavage stage. So that 6 carbon molecule gets cleaved into 2, 3 carbon molecules. Those 3 carbon molecules go through the energy harvest stage. This happens twice because there are 2 of these 3 carbon intermediates, but I'm just going to go through one of the processes here. So this 3 carbon intermediate is going to go through some reactions, one of which being the reduction of NAD+. So NAD+ goes into the system, gets reduced, meaning oil rig, reduction is gain, so it gains electrons to become NADH. This NADH is going to go to the electron transport chain. We're going to save that for later. And then ADP gains a phosphate to become ATP, ADP gains a phosphate to become ATP. These are some cool particles because they provide us energy, but 2 is not really that many. Remember, this happens twice. So for every 1 molecule of glucose, so far I am producing 2 NADHs and 4 ATPs. But I've produced 4 ATPs, and I used up 2 ATPs in the investment stage, so a 2 net ATPs are what's being produced here. In this energy harvest stage, the process of the production of NADH and ATP produces a pyruvate molecule, which is a 3 carbon molecule, and again, it happened twice, so I got 2 pyruvates. So I've gotten 2 pyruvates, 2 net ATPs, and 2 NADHs. That is glycolysis. The NADHs are going to go onto the electron transport chain. ATP is some sweet energy, but the pyruvates are what are going to continue into the link reaction. So next is the link reaction. So each pyruvate goes into the mitochondrial matrix. So pyruvates go into matrix to link reaction. And the link reaction connects glycolysis with the Krebs cycle. So there are 2 big things that happen in the link reaction. First is what happens with the pyruvates themselves. So the pyruvates each have 1, 2, 3 carbon molecules. One of those carbon molecules pops off. So one of those carbon molecules pops off, and it produces CO2. So for each pyruvate, I get 1 CO2. And because there's 2 pyruvates per glucose, that means each glucose gives me 2 CO2s. So now I have a 2 carbon molecule because that 1 carbon popped off. So I have that 2 carbon molecule. And now the next thing that's going to happen is this 2 carbon molecule is going to join with coenzyme A. Also, NAD plus is going to get reduced again. When NAD plus gets reduced, I produce NADH. Okay, so I have this 2-carbon molecule joining with coenzyme A. I end with still a 2-carbon molecule that's attached to CoA. And these are called acetyl-CoAs. Whoops. Okay, so in this process, no energy was made, but I did produce some of those high energy electron carriers, 1 per pyruvate, so 2 per glucose. I produced carbon dioxide when that carbon popped off, 1 per pyruvate, so 2 per glucose. And I ended with these acetyl-CoA molecules, 1 per pyruvate, so 2 per glucose. The acetyl-CoA is what's going to go into the Krebs cycle. So let me real quick get a new page here so we can see what happens in the Krebs cycle. So I'll make the Krebs cycle green. So the acetyl-CoA, Krebs. And remember, I have 2 acetyl-CoAs per glucose, so this happens twice. We're just going to look at one of those Krebs cycles though, for now. So the input mainly is acetyl-CoA. Acetyl-CoA from the link reaction comes in to the Krebs cycle. It is a 2-carbon molecule, and it joins with a 4-carbon molecule to make a 6-carbon intermediate. Some more stuff happens. Some more intermediates get produced. You don't need to know the intermediates, but what you need to know is in this cycle, 2 carbon dioxides are produced, 1 ATP is produced, 3 NADHs are produced, and these are produced the same way as they've been, and NAD plus getting reduced. So 3 of them are reduced to make 3 NADHs in the Krebs cycle, and we have a new molecule coming in also, called FADH2. This is produced when FAD is reduced. So this happens per turn. So I get 2 carbon dioxides per turn, so 2 carbon dioxides per pyruvate. So 4 total carbon dioxides produced if I count both pyruvates that are going through this process. So 4 CO2s, 2 ATPs, 6 NADHs, and 2 FADH2. And these high energy electron carriers, along with the other NADHs, are going to go to the electron transport chain. This ATP gives us a little bit of energy, but 1 ATP per pyruvate, meaning 2 per glucose, really isn't that much. So this is just kind of a plus, but this ATP isn't that special. The carbon dioxide that's produced in the Krebs cycle, and remember, is also produced in the link reaction, are not important for photosynthesis, are not important for respiration. They don't really do anything for us after this, but we breathe them out. And when we breathe them out, plants can absorb them through their stomata and use it in the Calvin cycle to make us more glucose that we can eat and do these processes over and over and over again. So it's all coming full circle. That is cellular respiration so far. We will talk about the electron transport chain and these high energy carriers in future lessons.